In this video, we're going to take a look at exponent rules and equations and apply all the rules to either simplify or solve the equations. In case you haven't seen the rules, here they are. I go through them in detail on the introduction or the basic exponent video. Let's dive right into the worksheet. You're going to see the instructions usually say simplify, use exponent rules, and typically they'll say don't use negative exponents. So we'll be aware of that as we move through these. So number one should be the easiest. It's just straightforward multiplication. The first thing you typically want to do with these problems is rearrange them. So multiplication can be done in any order. In other words, it's what's called commutative. So we're going to put all the numbers first. We like to rearrange it. Now we're going to take a look at the x variables. We have x cubed and we have x squared, and then there's y. So we arrange it like this, it makes it a little bit easier. So we can see 5 times 4 times 2 is just multiplication, so we'll have 40. Here we have like bases. Now remember, that is the key to all of these exponent rules. They must be like bases to use. So here we have like bases, multiplication, so we are going to add the exponents. So we have x to the fifth, and there's nothing else to go with the y, so the y is by itself, and we are left with our answer, 40 times x to the fifth times y. Our second problem is made a little more challenging because we have groups of parentheses as well as a power to a power rule here. But the first thing I want you to always do is look inside these parentheses and see if there's anything you can simplify it to. So we like to start in the parentheses. So I want you to notice we have an x, two x terms here. So if there's no number with the base, we can put a 1 there, and that's helpful for a lot of people because they tend to forget that. So we're multiplying like bases. We're going to add exponents. So we're going to have 2, and the x terms become x to the fifth, and y to the third has nothing to go with. And again, we're going to keep them grouped, and they're to the third power. Over here, there's nothing for me to do with that. I'm just going to keep it. There's nothing to simplify. And now we're going to use our power to a power rule because we want to lose these parentheses if we can. So remember, for a power to a power, we're distributing that exponent to each one. So the first one, the 2 is going to get it, so we're going to have 2 to the third. Now here, when the 3 exponent goes to the 5, it's a power to a power, so we're multiplying. So this becomes x to the 3 times 5, or 15. And then here we have y to the third, and that's going to be to the third. So you're going to multiply 3 times 3, we're going to have y to the ninth. Now these parentheses here aren't doing anything, so we can remove them. There's nothing to simplify. We have x to the negative sixth y. And now we're going to simplify and regroup. The 2 to the third, let's cross that out, and we can just write 8. If we rearrange these terms, we can kind of look at them. I'm just going to circle them. X to the 15th, x to the negative 6. We have like bases. Multiplication, so we're going to add. So we're going to have 15 plus negative 6, or 15 minus 6, which is just x to the ninth. We're done with those. We're left with y to the ninth times y's. Remember, you can put that 1 up here. It's like a placeholder for the exponent. And we're going to add 9 and 1, so we're going to have y to the 10th. So our answer is 8x to the ninth, y to the 10th. Number 13, we see our first look at division. And again, we can do something very similar and just kind of regroup things. Let me just write this a little bit bigger. So we have 15, x to the 7th, y to the 3rd, over, then we have 3, x to the 4th, y to the 8th. So you can kind of break it up into pieces. I like to look at it like this. We have 15 over 3. Notice there's no exponents. So we're literally doing 15 divided by 3. So we can write 5. With the x terms, we have x to the 7th divided by x to the 4th, so we have our like bases. And remember, with division, we're going to subtract. So 7 minus 4, we're left with 5x to the 3rd. Now here, there's a couple of ways we can treat this. We're going to stay traditional, and like bases of y, we're just going to subtract straight up. So we're going to do 3 minus 8. So we're going to get y to the negative 5. Now, we're not supposed to have negative exponents many times, so this can be rewritten as 5x to the 3rd. And that negative exponent can rewrite in the denominator as a positive exponent. So think of this negative exponent as a ticket to the denominator, if you want to think of it that way. Also, y to the negative fifth, if you want to look at it, is equal to y, 1 over y to the 5th power. Now, another way to do this, you may notice, so since you have the 8 down here and the 3 up here, wherever the larger number is, I could have just done 8 minus 3, and if I start at the 8, I keep it in the denominator. So that's just a little trick you can use moving forward, if you're comfortable. All right, so again, we still have that division or the rule for division with exponents up here. We got a lot of stuff going on in the numerator and denominator. Then we're going to look at the third power. So again, we're going to start inside the parentheses. I don't like the way this is arranged, so we're going to rearrange inside here. So we're going to have 4 times 8, cross those out as we go so we don't lose anything. Then we have x times x squared. And if you're feeling brave, you can go ahead and just do that in your head. Again, I'm not brave right now. We'll write that down. Then we have y to the third. And that's over, and there's nothing to simplify in our denominator, 16 x to the fourth y squared. So, and again, just to be safe, we're going to remind ourselves it's the third power. So looking right here, I can see x times x squared. Remember, that's x to the first, so we're going to add those, and then we have x to the third right here. Number-wise, we have 4 times 8, which we should know is 32 if we want to do that. There's other ways we can simplify. So let me rewrite this again. So we're going to have 32 x to the third y to the third over 16 x to the fourth y squared. And again, all of that is to the third power. Now, again, we can regroup here. So we have 32 over 16, which again is 32 divided by 16. So we simply have 2. Here we can use our little trick where we can start down here and we can do 4 minus 3 and leave the x in the denominator if we know this is going to be a fraction. Let's go ahead and give that a shot. So 4 minus 3, we're going to have x to the first, put the 1 there for now. And here we have y to the third over y squared. So 3 is larger, so I'm going to do 3 minus 2 and keep the y up there. So we just have y. And all of this is to the third power. So now each of these, we're going to distribute the 3 to each piece in the numerator and denominator. So we're going to have 2 to the third. Let's write that down here, 2 to the third, which is going to be 8. So we're going to have 8, and we'll have y to the third. And that's going to be over, and then we're going to have x to the third. And we are done. Okay, moving on to our next problem. So here you can notice there's a negative exponent outside the parentheses. We'll deal with that at the end. We have a little trick for that. Again, we're going to start on the inside. So we have 2x to the third y squared over 8x to the fifth y. Again, I'll put my reminder here. It's all to the negative 2. We know that. So we're going to have 2 over 8. If we look at it like this, 2 divided by 8. So that would be a decimal. So we're going to stay away from decimals as well. And we're just going to simplify this and reduce it by dividing numerator and denominator by 2. So we're going to end up with 1 over 4. And again, we can use our trick. We have x to the fifth in the denominator, x to the third here. So I can just do 5 minus 3 and leave it in the denominator. It saves us a little time. And here we have y squared over y. We can call that y to the first. So now we're going to do 2 minus 1 and keep y in the numerator because that's where the larger exponent is. And again, all of this is to the negative 2. This is where we get to use the rule when you have something to a negative exponent, you can make it to the positive exponent. Let's go ahead and do that. As long as we flip the fraction, we find the reciprocal. So this is going to be over 4x squared over y. Now I'm not dealing with that negative exponent. And to finish this off, we're going to distribute that 2 to the each exponent piece. So we're going to have 4 to the second. We're going to have 16. X squared squared, power to a power, we're going to multiply. So we're going to have to the fourth power over. And remember, this is y is just being squared. If you want, you can put a 1 and you can multiply. Power to a power we multiply. So you're still going to have y squared. And we're done with that one. Next problem. So we got a little bit of everything going on here. This is where the entire fraction's not to the negative 2. So this is where I'm just going to go ahead and distribute that power. You could distribute a negative power as well. So this is going to go over to 4 to the negative 2. Don't love it, but we'll deal with it. And then we're going to have x to the 1. 1 times negative 2 is negative 2. And this I like. Negative 2 to the negative 2. We're still multiplying, so we're going to get to the positive fourth power. And that's all over 2x y to the third. So I'm a little bothered by the 4 to the negative 2. So realize 4 to the negative 2 is equal to 1 over 4 squared, or 1 over 16. So we can take this 4 to the negative 2 and cross that out and put it down here, and it's going to be multiplication there. So as we simplify this, we're going to have 32 in the denominator. So let's go ahead and set that up. So when you can do one piece at a time, take it out of the way. Now down here we have x to the first. We can either do negative 2 minus 1 and leave it in the numerator, or realize that 1 is larger and we can do 1 minus negative 2. Let's write that down for you. And that's really going to be 1 plus 2. So we're going to have 3 if we start in the denominator. So it's going to be x to the third. So those are taken care of. And y to the fourth, we have the fourth degree is larger than the third. So again, we're just going to subtract, and we're starting up here. So we'll leave our answer up there. So we can do 4 minus 3, which is 1. So y to the 1, or we can just leave it as y. And we've taken care of those. And that's the final answer. So it looked pretty challenging, but it wasn't too bad. Next up, again, we have our negative exponents. We have everything going on. So there's nothing to do inside the parentheses. So let's go ahead and distribute that negative 2 right away. So we're going to have 2 to the negative 2, x squared to the negative 2. So again, we're just multiplying. So it's going to be x to the negative fourth, negative 3, and it's going to be raised to negative 2. Again, we're going to multiply power to a power. We have to the sixth. There's nothing to do here with x to the negative 5 and y squared. And I'm not going to change this around at all because I can still use my multiplying like bases rule. So let's go ahead and take a look at each piece. So first up, 2 to the negative 2, we know is 1 over 2 squared. And we'll clean that up in a minute. Now we have x to the negative 4 times x to the negative 5. Like bases, again, we're adding exponents. So this is going to be x to the negative 9. We're done with those. Then we're left with y to the sixth times y squared. Like bases, we're going to add exponents. We have y to the eighth. So if we write this as a fractions, because we know we're going to end up having this 1 over 2 squared in the denominator is going to be 4. X to the ninth is going to go in the denominator as x to the positive ninth. And then y to the eighth will be in the numerator because we're not going to move that. And we are done. That is the answer. Number 8 looks tough, but let's take a look. This is where I want you to notice whenever you have something raised to the 0 power, that rule means it's equal to 1. So all this stuff in here is being raised to the 0 power. So this whole thing is simply equal to 1. So the problem is actually 3x times 1. So your final answer is simply 3x. All right, now we're moving on to solving equations. And the deal with these is you're always going to be looking for a like base. The goal is to have a base equals some value up here equals the same base equaling some other value up here. So these two bases have to match. And if that's the case, we know the exponents have to equal. So an actual rule you might see is that if b to the x is equal to b to the y, then x must equal y. Basically, you're just setting the exponents equal to each other if everything matches up. So first thing I'm going to do is look at this left-hand side, and I'm noticing it's a power to a power. So I have 2 to the x plus 1 to the 4. So this 4 has to multiply, and it's going to multiply all of x plus 1. So we're going to have 2 to the 4x plus 4 equals, we don't want 8. So 2 is our base. So we're going to find a way to write 8 using 2 as a base. So 8 is equal to 2 to what power? We should know it's 2 to the third, and if not, you should start making a list of tables where you have 2 to the first, second, third, all the way down. Use 2, 3, 4, 5. Those are the most common. So we're going to replace 8 with 2 to the third. So that means the 2's match up. So 4x plus 4 must be equal to 3. So we're just going to write that down. 4x plus 4 equals 3, and we're just going to solve it. Subtract 4 from each side. We're left with 4x equals negative 1. Divide by 4. So in this case, x equaling negative 1/4 is our solution. Next up, one of the things you can start to look for when you're doing these problems is seeing if you can figure out what the base is. Usually you'll have the smallest base there. Like in this case, 3. Can the other numbers be written using a 3? So 9 is 3 squared. So let's go ahead and write that over here. 3 squared equals 9. So we can do everything at once here. So we have a power to a power with the 2x and the 4. So this is going to be 3 to the 8x equals 1 over 3 squared, because 9 is 3 squared, but it still doesn't match up. You cannot have the 1 over. So we're going to rename this using negative exponents. So we know this means 3 to the 8x, and this can be rewritten as 3 to the negative 2, remember. So now the 3's match up, so that means 8x is equal to negative 2. We can divide both sides by 8. and we're left with x equals negative, and we can just reduce this to 1/4, or if you prefer decimals, negative 0.25. And that's all there is to that one. Number 11, getting a little tricky here. You may recognize 125, what that is. It ends in a 5, so 5 to some power would work. So let's just write a few things down to help you out. 5 to the first is 5, 5 squared is 25. If we multiply that by 5 again, we get 125. So we could rename 125 as 5 to the third. Now, the square root is bothersome. I need you guys to remember one of the rules, that the square root of a number means that number is being raised to the 1/2. So we can lose the square root and raise it to the 1/2 power. Now over here is something we've seen already. Power to a power, we're going to multiply. So we're going to have 5 to the 3x, and that equals 5 to the 3 to the 1/2. So power to a power, again, we can multiply. We get 5 to the 3x equals 5 to the 3/2. So we have bases matching up, and we can set the exponents equal to each other. 3x equals 3/2. Divide both sides by 3, so x is equal to 1/2. And yes, there are other ways we can solve this. Another way to get rid of the square root is you could have squared both sides and applied the rules that way. So you do have other options. Number 12 uses a base of e, because e is very common. If you haven't seen it already, you'll see it in your math future. But again, we're recognizing we want e, so over here we want to get it as a base. So we'll apply the negative exponent rule. That's just e to the negative 2. And up here, let's take a look at this. This is going to be e. We can do this different ways. We're going to write this as e to the x plus 3, like bases we multiply, over, now we're going to power to a power, we multiply. Sorry, we said like bases we add. Here we have e to the 4x. So now we have like bases with division, so we're going to subtract. So you're going to end up doing x plus 3 minus the 4x. So just be careful here. We're going to have negative 3x plus 3, or 3 minus 3x if you prefer. So this is going to reduce to a single base of e to the 3 minus 3x. So that was a lot. But we have what we wanted. We have the bases matching up, e matching with e. And that leaves us with negative 2 equaling 3 minus 3x. We have x on the right-hand side. That's okay. We'll just move all the numbers to the other side. And we're going to have negative 5 equals negative 3x. Dividing both sides by negative 3. We're left with x equals a positive 5/3. All right, number 13, seems like they're messing with you a little bit because it's not an equals anymore. We have subtraction. Remember, our goal is to have a base to a power equaling a base to a power. We don't want subtraction. We don't know how to work with that. So what we want to do is we want to move this over to the other side. So we're going to have 27 to the x equals, and if we do that, we're just adding it. We have the square root of 3. So now, again, we need like bases. So again, if you were to write these out, 3 to the first is 3. 3 squared is 9. 3 to the third is 27. So we can replace 27 with 3 to the third, and it's to the x, so a power to a power, we are going to end up multiplying, so let's go ahead and write that down. And then we're going to use that rule before, remember, square root of x is x to the 1/2, so the square root of 3 means 3 to the 1/2. So we have bases matching up, so that leaves us with 3x equals 1/2. We're going to divide both sides by 3. That leaves us with x equals, same as multiplying by 1/3. So we're left with x equals 1/6. Okay, next up. So now we have a 16 and an 8. I'm tempted to use a 4, but 4 to a power does not give me 8. So let's see if we can go even lower. When you have 4, a lot of times think about the 2. 2 to the first is 2. 2 squared is 4, so there's that 4 we were talking about. 2 to the third is 8, which is what we need. 2 to the fourth is 16. So that's something to be aware of. So now the 16 can be rewritten as 2 to the fourth. And remember, this is the cube root, or the third root of 16, so that's going to be written as to the 1/3 power. 1 over 8 to the x, so we can write this as 1 over 8 is 2 to the third, and that's all to the x. Now we're going to use our power to a power rule here on the left. So that's going to be 2 to the 4/3. Now, here's an interesting thing. Let's write this over here. 1 to any power is always equal to 1. So when you write 1 to the x, we can immediately replace that with just 1 over. And then we have 2 to the third to the x. That's going to be 2 to the 3x. And again, we could have right away rewrote this as 2 to the negative 3. And then power to a power, we get our negative 3x. But I just wanted you to see that. So we have 2 to the 4 thirds equals 2 to the negative 3x. Again, those bases match up. That leaves us with 4 thirds equals negative 3x. Divide both sides by negative 3. It's like multiplying by negative 1/3. So we're going to get x equals negative 4/9. All right, last couple here. This is just using the idea of rational exponents. So your ability to rewrite these. So remember, if it's on the bottom, the denominator in the exponent, that's really the root. So this means the square root. I don't need to put the 2 there. It's understood. You can if you want. And then here we would have 9. And then on top is the power. So all of this is going to be raised to the third power. So we're just doing the square root of 9, which is 3, and then raise it to the third power. So 3 times 3 times 3, simply 27. And here we are. I believe this is our last one. I want you to realize here that when you have to a negative exponent, it is not a negative number. Remember, it just means division. So the first thing you may want to do is just rewrite this as 1 over 8 to the positive 2/3. All right, so now we've gotten rid of that idea of negative numbers because that's not what this is. So we can do 1 over, and the 3 is in the denominator this time, so it's the cube root of 8, and the power is 2, so it's going to be squared. So it's 1 over the cube root of 8, which is 2, squared. Our answer is 1/4. So again, always take a close look, see what rules you need to apply, see that you have like bases, and see that you have a reason for each step. I hope that helps.